So, okay, let's talk about one question from last period and then we'll move on to lesson 2. So the last question, if we want to solve for x here, so we use the same strategy. So this is log, we can convert this into index form. So basically it's asking you x to the power of 3 over 2 equal to 27. What is x, right? So we convert that into the exponential form. So that would be x to the power of 3 over 2 equal to 27. Does this make sense? Okay. No, you can't guess. Okay, so with this one, let's say x to the power of 3 over 2. How do we represent it in this third way? So we know if it's in the numerator, it's actually the power. If it's in the denominator, it's the third. So in this way, we know actually this guy equals to this, right? So now you have 3 here. So you can actually write in this way. See? So which means like this, something like this. So you can write this way in. Okay, therefore, if we think this is one guy, all right? So sometimes we use this strategy quite often. Let me summarize this strategy is that you think a whole thing as one small letter. You use one letter to represent the complicated thing. So if we represent this thing as another guy, so this another guy to the power of 3 equal to 27. So we know this guy, the red circle will equal to something to the power of equals to the power of 3 equal to 27. This one definitely will equal to 3. Does this make sense? So x equal to 9. Okay. For today's lesson, before we look at the questions, I would like to we're gonna learn how to sketch the basic graph for exponential, all right, and for log. How do we sketch the basic shape? The basic shape for ax, if a is bigger than 1, all right, so it would be something like this. Let me ask you, when x equal to 0, what do you think the y value would be? When x, yeah, it's 1. So it definitely would go through this point, okay? So this one would be something like this. This is the basic shape. Okay, this is the basic shape of ax. All right. And how about log ex? So we know these two guys, they are inverse function. They're inverse function. Remember, reflects over y equal to x. All right. So this one would be the basic graph. It's not nice, but this one would be the basic graph for log ex. All right. So now, if we know these two basic graph, we can use DRT to do some sketching. For example, let's look at question 1. Do we have any dilation here?
No.
Do we have any refraction here?
No.
Do we have any translation here?
Yes.
We translate 1 unit to the 1 unit to the left, 2 units down. Okay. So basically, this one is y equal to 0, right? X-axis means y equal to 0. And now we translate 2 units down, which means we have an asymptote when y equal to -2. So that would be 1 point, 1 mark. And then you know the shape is like that. So we still want to find out x-intercept and y-intercept so that we can connect them. How do we find x-intercept, y-intercept? We just solve equation, right? So we make y-intercept, we make x equal to 0. So e 0 plus 1 minus 2, that would be e minus 2. That would be y-intercept. Okay. And then x-intercept is this guy equal to y equal to 0. Then we solve it, which I think we know how to solve it, right? So x plus 1 equal to 2. Therefore, x plus 1 equal to log e2. Okay? And then x equal to log e2 minus 1. So this would be x-intercept. You don't know. Which step you stop?
Can you slow down a bit?
Alright. So here, it makes sense?
Yeah.
For here, if we want to find x-intercept, we make y equal to 0.
Yeah.
Make sense? Alright, and then we move the 2 to the right.
Yeah.
And make sense? Here, it's same as... So, yeah, we change the exponential to log.
Yeah.
So e to the power of 2 equal to x plus 1. To the power.
So you just move the 1 over that.
That's right. Makes sense, right? Okay, all good? Alright, however, what is tricky is that if, let's say if this is exam 1 question, you can't use your calculator. How do you know roughly where you're going to plot the intercept? So you need to know roughly where this position is. So like I said just now, e equal to 2.71 something something. So let's assume it's 2.7. Then this thing would be, y-intercept would be 0.7. All right, it's a approximate. It's not exact value. So we know that the y-intercept would be roughly 0.7, which is here. So this will be y-intercept. However, when you label here, we don't label 0.7. We label the exact value, which is e minus 2. But the reason why we find out 0.7 is because we want to know where roughly we're going to plot it. Make sense? And how about this one? How about the x-intercept? Where do you think roughly, what number they roughly equal to?
X-intercept, right?
Don't use calculator if this is exam 1.
Not this, negative 0.
Okay, so let's look at this. What does this guy equal to? 1, yeah? What does this guy equal to? 0. Make sense? Then 2 is less than e but bigger than 1, which means log e2 is bigger than 1 but less than 0. So this guy is roughly 0 point something. 0 point something minus 1, that would be negative 0 point something. It would be roughly here.
So it's between 0 and 1 and negative.
Yeah, it would be roughly here. Negative 0 point
So
something.
it doesn't matter if I would roughly more towards the negative or towards 0?
It doesn't matter that much without technology. So this one you label log e2 minus 1. Alright. And then we know this point originally is 0.1. Now it translates 1 unit to the left. Okay, that will become negative 1. And then 2 units down, negative 1 and negative 1. So it would be roughly here. Okay, so now we have 3 points. We can simply connect them. Alright, so it was something like that.
What was your third point? What is your third point?
This point?
Yeah.
It's negative 1, negative 1.
Oh, because you translate.
Because its origin is 0, 1.
Yeah.
Now you translate 1 unit to the
Left.
left. So this one will be negative 1.
But then you translate 2 units down.
Yeah, so 1 minus 2 equals to negative 1. Maybe I'll show you an example of dilation. Y equal to 3 log e2x. Alright, so this one, we only have dilation, we don't have any translation, we don't have any refraction. So when we talk about the dilation, we know the basic graph for this one is something like this. Yeah, something like this. Just now we already figured out. Alright, so the dilation for this one, how do we find the dilation? Dilation is just become factor or skinnier, okay? So basically, if you find out the intercept, the shape will automatically come out. Okay, so we just find out the x-intercept, the intercept for this one. So y-intercept would be, we don't have y-intercept here because it doesn't translate. And then x-intercept would be y equal to 0. Therefore, 2x equal to 1. Alright, if you want to do more, is you divide it by 3 for both sides. And then e to the power 0 equal to 2x. Yeah, because you convert this into the exponential form. So x equal to half. Alright, so which means the graph would be, this is half. Alright, this is half. Okay, just go like this way.
Wait, what did you do? 3.
3? It's original there. How do I get rid of it, you mean?
Yeah.
Because you divided by 3, 0 divided by 3 equal to 0. Just like that.